On May 2, 1944, German artillery batteries near Targu Fumos in northern Romania were doing what they always did. They sat tucked behind reverse slopes, hammering Soviet approach routes from positions no standard Red Army gun could reach. 48 hours later, those same German guns were gone, crews scattered, ammunition columns wrecked. The sanctuary that distance had given Panzergrenadier Division Grossdeutschland was simply erased. The weapon that did it existed in numbers so small it almost defies belief. Only 37 were ever built, yet each one solved a math problem that had broken Soviet artillery since Barbarossa. How do you kill German guns that fire from beyond 20 kilometers, where most Soviet weapons stop being useful? For most of the war, the answer had been, you don't. Grossdeutschland at Targu Fumos was using concealed batteries placed on terrain features that hid them from Soviet forward observers. Those batteries could rake every approach route the Red Army tried to use and stay invisible to anyone shooting back. The Soviet 122mm A-19 core gun maxed out at 20.4 kilometers. The standard 152mm ML-20 gun howitzer reached only 17.2 kilometers with standard projectiles, and it struggled against hardened German positions ringed with earth and timber revetments. The German artillery officers had done the math correctly. Their positions sat past the practical reach of nearly everything the Soviets owned. Soviet infantry and armor were advancing into a kill zone they could not silence. Commanders needed a weapon that could find those guns where the Germans felt safe and hit hard enough to force displacement or destruction. But the answer had been quietly built years before, in a factory at Stalingrad. The Soviet Artillery Directorate had commissioned the Br-2 back in 1935 as part of a heavy artillery modernization program. The plan called for 3 specialists: a 152mm long-range gun for counter-battery work, a 203mm B-4 howitzer for sieges, a 280mm Br-5 mortar for fortifications. The design contract went to Barricade plant in Stalingrad, the heart of Soviet heavy gun manufacturing, with the specialized tooling and metallurgical know-how needed for high-pressure artillery. The design brief was brutally simple. Reach 20 to 25 kilometers. Carry a shell heavy enough to destroy, not just suppress. Every other quality, weight, mobility, rate of fire, could be sacrificed. The Br-2 was built as a counter-battery specialist, nothing else. The tracked carriage, borrowed from the B-4 howitzer and Br-5 mortar, accepted slow displacement in exchange for cross-country mobility under 19 tons of steel. Soviet doctrine wanted reach, and the Br-2 delivered it. The gun fired a 48.9 kilogram separate loading high-explosive projectile at 880 meters per second. Maximum range, 24,740 meters. Caliber, 152.4 millimeters. Barrel length, 7 meters. Combat weight, roughly 19,000 kilograms, which meant a large crew and dedicated heavy tractors anytime the gun needed to move. The interrupted screw breech and hydropneumatic recoil system were engineered to absorb forces that would have destroyed conventional field carriages. The tracked configurations spread the load across soft ground that would have bogged down wheeled artillery. Rate of fire took the punishment. Experienced crews managed 1 round every 2 minutes. Every shot was a planned engagement, not suppressive fire. But that slow cadence was the point. The bagged propellant charges could be tuned for specific ranges and trajectories. Steel fragmentation shells could be set for instantaneous burst against exposed gun crews, or delay fused for German earthworks. The combination of reach, accuracy, and shell weight made the Br-2 the only Soviet weapon that could systematically dismantle an enemy artillery network from beyond that network's own reach. Soviet doctrine kept these guns under tight control. Br-2s lived in separate heavy gun regiments of the reserve of the Supreme High Command, never dispersed to divisions. During Targu Fumos, the Second Ukrainian Front pulled them forward for counter-battery duty, positioned far enough behind the line that German guns could not reach them, close enough that German batteries could. The reconnaissance net feeding those guns was sophisticated. Sound-ranging stations picked up acoustic signatures from German firing. Aerial observers confirmed battery locations and ammunition dumps. Flash spotting teams logged muzzle signatures. Ground reconnaissance verified coordinates when terrain allowed. Soviet artillery intelligence in early May 1944 was identifying German positions faster than the Germans could move them. And here is where the Br-2's discipline mattered. Fire missions were not blanket bombardments. With only 37 guns in the entire Soviet inventory and a brutally slow rate of fire, every shell had to count. Battery commanders calculated firing data using meteorological inputs, surveyed gun positions, propellant temperature, and barrel wear. Adjustment fire established the range with ranging shots, then concentrated salvos landed on the active German battery, the command post, or the ammunition point that was actually doing damage. The Br-2 was a precision instrument, used as a precision instrument. The German artillery network at Targu Fumos was not ready for this. Positions that had felt secure behind reverse slopes were suddenly under accurate fire from weapons the Germans could not see and could not reach. Grossdeutschland reports through early May described sustained counter-battery fire disrupting batteries and ammunition columns. This was not random harassment. It was deliberate engagement of identified targets by heavy-caliber weapons, and the Germans recognized it. The response was forced displacement, over and over. Crews abandoned carefully prepared firing positions. They lost surveyed data, lost protective earthworks, lost the registration that made their own fire accurate. Ammunition columns took casualties during movement. The supply of shells that German defensive fire depended on began to choke. The cost compounded fast. Every forced displacement burned through prime movers, fuel, and crew labor that should have been firing missions instead. Grossdeutschland dispersed ammunition into smaller dumps to reduce vulnerability, which tripled the number of transport sorties needed to keep guns supplied. Battery positions were occupied for shorter and shorter windows. Movement timing slid into darkness or bad weather, which improved survival but wrecked responsiveness. The whole German artillery system started to lose coherence. If you are interested in how engineering trade-offs and industrial choices actually decide battlefield outcomes, hit subscribe and stay with me. I cover the weapons that shaped the Second World War every week, and the next one will not disappoint. So how exactly did 37 guns drag an entire German division into logistical paralysis? The arithmetic is the strange part. Total Br-2 production from 1937 to 1940 reached only 37 units, all built at Br-2 in Stalingrad. The tracked carriage and precision-machined barrel demanded more time and skilled labor than standard artillery plants could provide. Each gun was a strategic asset, allocated personally by front commanders. Against that scarcity, the German countermeasures consumed hundreds of tons of fuel, thousands of man-hours, and scarce transport capacity to evade roughly a dozen guns in the entire Targu Fumos sector. Each battery displacement burned fuel and vehicle time equivalent to several fire missions. Dispersed ammunition storage doubled or tripled the logistics load compared to concentrated dumps. The cost of avoiding Br-2 fire exceeded the cost of the Br-2 itself by a wide margin. That was the Soviet doctrine in microcosm. Achieve strategic effect through operational concentration, not numerical parity. By massing scarce heavy artillery against a narrow sector, the Second Ukrainian Front created local firepower dominance, even with a handful of guns. The Germans were fighting an artillery battle they could not win conventionally. They did not have weapons with the range to engage Soviet heavy batteries, and they could not stop the systematic suppression of their own. The Br-2 outlived the war it was built for. Surviving guns were modernized to Br-2M standard, with wheeled carriages that fixed the original mobility problem while preserving ballistic performance. The upgraded version stayed in Soviet inventory until the 1970s, serving in strategic artillery units through the early Cold War. One original Br-2 still exists today, displayed at the Military Historical Museum of Artillery, Engineer and Signal Corps in St. Petersburg. The tracked carriage, the interrupted screw breech, the 7-meter barrel, all preserved. Built in numbers so small that each surviving example is a serious historical artifact in its own right. The lesson of the Br-2 is not technical brilliance, it is relentless adequacy in a specialized role. The weapon succeeded not through revolutionary innovation, but through systematic application of proven ballistic principles to solve one specific operational problem. Soviet doctrine that emphasized reconnaissance fire integration, careful target selection, and concentration of scarce assets let 37 guns shape battles involving hundreds of thousands of troops. Effectiveness mattered more than volume. That same principle is alive on modern battlefields. Ukrainian forces in 2022 used long-range precision fire to suppress Russian artillery, leaning on Western-supplied systems to reach guns beyond the envelope of shorter-ranged weapons. The tactical problem that drove the Br-2, reaching enemy guns that conventional artillery cannot touch, is the same problem being solved with HIMARS today. The Br-2 that engaged Grossdeutschland's artillery won its battle through systematic adequacy applied with operational intelligence. Simple enough to manufacture under wartime conditions, effective enough to justify strategic allocation, durable enough to serve for decades after the war that created it. 37 guns, 48 hours, one sanctuary erased. That is the math that mattered at Targu Fumos.